Hey guys, today I will continue again talking about the same problem. Again, I know about climbing stairs, but today I'll be talking about a different approach to solving the recurrency. Okay, so again, let's recap the recurrence relation that we discovered. The recurrence relation was f of n equal to f of n minus 1 plus f of n minus 2. Again, this means the number of ways to climb a staircase of size n. It will be the number of ways to climb a staircase of size n minus 1 plus the number of ways to climb a staircase of size n minus 2. I know we saw it so many times, it's getting boring, but yeah, I want to discuss newer solution, okay? Okay, so previously we discussed that the runtime for this recurrence relation was O of 2 power n, okay, and that was unacceptable. Why? Because it's too slow. Okay. So now we're wondering, can we do better? And the answer is, well, I hope it's yes. Okay, so how can we do that? The way we can make it faster is by doing something or using something called bottom up, DP. Again, DP means dynamic programming. Okay, just DP means dynamic programming, but now we're going to be talking about something called the bottom up. Okay, so what do I mean by that? What do I mean by bottom up? Okay, so let's think about it. Let me put it in the cloud. If I want to, for simplicity, when I calculate f of 4, okay, well, based on my formula, it will be f of 3 plus f of 2. And then f of 3 will be f of 2 plus f of 1. This will be f of 1. We do not have any staircase with 0 steps, so we cannot have f of 0. And this will be f of 1. Okay, now what I could do, I could build an array. Okay, and where the indices represent n. Okay, so it's an array. And the indices, so index is 0, 1, 2, 3, 4, 5. Okay, and the number inside the array will be the number of ways to climb the staircase. So for example, I know that f of 1 is 1. Okay, the number of ways to climb a staircase of size 1 will be 1. It's one way. So I can store 1 here because that's index 1. Okay, so the index here represents n, which is the number of steps in the staircase, of the staircase size. Okay, I also know that f of 2 is equal to 2. You have a staircase of size 2, there's 2 ways to climb it. So I can stick 2 over here. Okay, well, if I want to get f of 3, well, what I have to do is to add these 2 guys and store the result in the one after that. So I'm going to add these 2, and when I add them, 1 plus 2 is 3. I can say 3 here. Okay, what if I do f of 4? Maybe I can write on the other side. Well, f of 4, well, it will be f of 3 plus f of 2, which I do have. I do have both of them. So all I have to do is to take my pointers and shift it 1 step to the right. So f of 3 plus f of 2, 3 plus 2 is 5. What if I want to get f of 5? So it will be f of 4 plus f of 3, which means all I have to do, shift this guy to the right, which is basically just 2 pointers, add f of 3 plus f of 4, 3 plus 5 is 8, and so on and so forth. Okay? So instead of doing recursion like we did last time and creating so many overlapping subproblems, for example, this guy, this guy, this guy, all these are overlapping, all I can do, I can start from the very basic step or the base case, which is f of 1 and f of 2, and then build my array from there. Okay, build my solutions from there one by one. All I have to do is to slide this guy to the right, one step at a time, one step at a time, one step at a time. Add these two, and then the result will be there. Add these two, and then the result will be in the next block. Add these two, the result will be in the next block, and so on. That's the idea. This is called bottom up because we're starting from the base case, which is n is 1 and n is 2, and then we're getting the solutions for anything bigger than 2 by just adding the two previous values. So it's just a for loop, basically. Okay? Just a for loop. Okay. So let's maybe do one more. If I want to get f of 7, well, how big is my array? I need, if I get an array over here, n here is 7, so I want my very last index to be 7, and every array starts with index 0, so I need an array of size 7 plus 1 will be 8, okay? So for any input n, the array size will be n plus 1, okay? And again, as always, we'll populate index 1 with 1, index 2 with 2, and then we can rebuild and populate the array block by sweeping through it with 2 pointers. And think of it as a window, sliding pointers. Okay? That's actually the idea. That's basically the idea. And there are no overlapping subproblems here, if you notice. Okay? So, okay, I think we can start coding it. I think that's it's basically a straightforward solution. It's called the bottom up because you're starting from n equal to 1 and n equal to 2, and from there you're building the answer for n 3, n 4, n equal to 5, n equal to 6, and so on. All you're doing this by just one array, and that's about it. You're just populating it with a for loop. Okay, so let's maybe stick this over here. There'll be size 8. Okay, so I'm gonna let's go write some code. So this is that was the last this is from the last video. So let me comment it out. Okay, so again, let's go over the base case. If n is less than or equal to 2, so if n is 1, return 1. If n is 2, return 2. So just return n. Okay. If n is 1, return 1. N is 2, return 2. So basically, if n is less than or equal to 2, just return n, whatever value it may be. Could be 1 or 2, or just returning it. Okay. Otherwise, now we need an array. Okay. So how big is our array? Well, first, let's just give it a name. Let's call it num of ways. Okay, I need to create some empty array. We can just fill it with a bunch of zeros. So in Python, you can just do it like that. And we need it size of n plus 1. Okay. yn plus 1. If I go back to what I showed you earlier, we have n equal to 7. If n is 7, we need 8 spots. Okay, from index 0 all the way to index 7. Okay, so we need 8 spots, and yeah, so it's n plus 1 basically. Okay. Okay, so let's go back. Okay, so I have my array. I just called it number of ways. That will represent number of ways to climb the stairs. And I know for index 1, when n is 1, there's one way to climb the stairs. When n is 2, when I have 2 steps, there are 2 ways to climb the staircase. Okay, so that's n equal to 1, I have 1 way, n equal to 2, I have 2 ways. These are the base cases. Okay, anything bigger than 2, now we can create our for loop and iterate over the array and populate it. Okay, so for I in range, we can fill this in later. We can think about it in a second. I'm gonna put question marks here, and I need to populate my array. Okay, so the number of ways, I'm gonna put brackets. We're gonna put our recurrence relation, which is I am adding the neighbors, okay, the 2 previous neighbors. Okay, so I'm gonna put empty bracket here plus empty bracket here. Okay, so let's go back to the diagram. What we did over here, we said you look at this, our 2 pointers. In order for me to populate index 3, I need to add index 1 plus index 2 and then shift it. If I want to get f of 4, I need to add f of 3 plus f of 2, shift it. F of 5, I need to add f of 3 plus f of 4, shift it, and so on. Okay? So because of that, go back now. Whichever number I'm going to put here, this will be I, that will be, in that case, I minus 1, and then I minus 2. The one before it, the index before it, and the index before the one that's before it. Okay? So the index, the value 1 less than my current index, and then 2 less than my current index. That's basically the recurrence relation that we had earlier. Okay. And we're doing this starting from where? What is the first value we're starting from? So let's see. Can we start from 1? No, we cannot start from 1 because it will be a negative value. The very first value we're populating is index 3 because index 2 is populated, index 1 is populated, so we want to start from index 3. Okay. Okay, so sorry, index 3. That's correct. So that will be 3. So the very first value we want to populate, which will be 3. Okay, so I really want this to start from 3 because that's the very first value I'm missing. I'm not missing index 1 because it's already populated. Index 2 is populated. I need to populate index 3. That's the first one. Okay. Now, what's the last number I want to stop at? What is the last index I want to populate? Well, I want to populate until n. So let's go back. I want to keep going until the very last index. If you look at, for example, here, I'm adding these 2. So I'm adding these 2, and then the answer will be stored here. So these guys are moving together. Yes, I'm gonna keep adding and moving, adding and storing, adding and storing, adding and storing. So the very last index that I'm storing my answer will be over here, okay? Which will match the same value as n, okay? So what I'm trying to say is and I hope it makes sense, is the very last index here should be n plus 1. Okay, why it's not n? Because in Python, range stops 1 less than this value. Okay? So you want to make sure this value, the last value stored, is n, the value I'm trying to reach, okay, which is the very last index. Okay. And we put a plus 1 here because Python, by design, the range iterator or function, it stops 1 less than this number. Okay? I hope that makes sense. Try to think it through and convince yourself that this is correct. But the bottom line is, this is a for loop to populate an array of zeros. This array starts with zeros, and we're iterating over each two neighbors, and we're moving. Adding them, we're moving. Adding them, and we're moving. Okay, one by one. Until the very end of the array. And we're starting from index 3. We need to populate index 3 first. And the last index we're populating will be index n. Okay. Okay, so where is our answer? Well, let's see. Our answer is stored at the very last index. Yes, our answer will be stored here. Finally, the answer will live here. If we maybe let's walk through this quickly. 1 plus 2 will be 3, and then move to the right. 2 plus 3 will be 5, and then move to the right. Oh my god, so much work. And then 3 plus 5 is 8, and then move one more to the right. Almost there. It'll be 11, and then the last one, which is index 7, will be 19. Okay, so my answer basically lives at the very last index, which matches the value of n, index n. Okay, so what I'm trying to say is we need to return the value in the very last index. So we're gonna return, once I'm done populating my my array or my list, whatever you call it, then I'm need to return the very last value. And in Python, you could just put n. That's the very last value. How do I know it's the very last value? Because remember, our array has a size of n plus 1. Okay, it goes from index 0 to index n. So that's the last index. Or you could put -1, but that's a different way of doing it in Python. But that should work. I hope that's clear. Let's run it here. Okay, and if you notice, last time we had 40, and 40 was actually could not run because it was too slow. But if you, let's even make it 60, okay? Oh, okay, so we're not allowed to put more than 45. Okay, well, I guess I can try 45. Okay, notice it's pretty fast. In the previous solution, the top-down solution, it was O of 2 power n, and it didn't work, was 40 because it was too big. Okay. Here, the runtime, which I hope you can see it, it's O of n. Why it's O of n? Because we're doing one iteration over the array, single iteration. Okay, single iteration. That's O of n runtime. That's why it's much faster. So I hope this solution was clear. It's called dynamic programming bottom up. Okay, bottom up because we're starting from the base case and we're growing upwards to the more complicated case. It's just a for loop. It's very simple, honestly. Just a for loop, and you're just populating an array using a for loop. Okay. Anyway, so I think there will be one more video about the top-down GP top-down. We will revisit the top-down one more, and I think there will be one more video also about a different way of doing climbing stairs. But yeah, let's see if I have time, honestly. Anyways, thanks for watching.